Hi, welcome to this video. Today we're going to show you how to derive voltage and current dividers. The goals of this video is going to be through a three-step process. When, why, and how do we derive these equations? This is going to be our voltage divider circuit. We notice that there's a voltage source and two resistors. When we see a circuit like this, we should notice that the resistors are in series. We know we can add resistors that are in series. Equation REQ equals R1 plus R2. We should then recognize what is this question asking us to solve for. In this circuit, we want to find V out being the voltage over resistor 2. So how do we solve for V out? Well, we know we have voltage, current, as well as resistance. With these three variables, we are going to use Ohm's law. Ohm's law is voltage equals I times R. We notice that we need to solve for the total resistance in our total voltage out equation. Luckily for us, we noticed that they were in series, so we're going to just use the equation found beforehand with the REQ equals R1 plus R2. And that is our total resistance. Next, we need to solve for the total voltage. Now looking back at our previous circuit, we notice that the Vs is our total voltage through the circuit because Vs is our only voltage source through the circuit. So we plug back what we previously just found with our total resistance and our total voltage into our Ohm's law equation, resulting in the Vs equals I times our total resistance. We can now rearrange this equation found for our total voltage. That way, we can get our current. When we find our current like this, it will allow us to plug it into our V out equation. Now for our V out equation. Once again, we're going to use Ohm's law. So V out equals our current times our resistance through the second resistor. Now we're going to plug in our current that we found from our total voltage equation. So current goes into the voltage out equation. This will now result in our final equation. V out equals R2 over R1 plus R2 times Vs. We finally derived the equation. So why did we do this? We can always use this equation when we notice that we have two resistors in series with a voltage source and we want to find the voltage through one of the resistors. Now let's derive a current divider equation. We have a current source that goes into two resistors that are branching into different branches with different currents. When we see this, we notice that our resistors are in parallel, and the current through those branches are going to be different. We know that the resistors are in parallel, so we're going to use our resistance parallel equation. REQ equals R1 parallel to R2, which is also written as R2 times R1 over R1 plus R2. How do we solve for the current through the second resistor? We're going to use Ohm's law. So we can write this with our variables with our total resistance being Vs equals the current Is multiplied by the total resistance found. How do we find the current through the second resistor? We solve for the current 2 with Ohm's law. Current 2 equals Vs over the second resistor. Now remember when we found the voltage using the previous total voltage equation. We're going to plug in our Vs into our I2 equation. So we get a final equation of I2 equals Is multiplied by the total resistance over R2. We then know we can cancel out our R2s, thus resulting in a final equation that has been simplified. So I2 equals Is multiplied by our resistance in parallel equation. So why did we do this? We have two resistors that are in parallel with a current source and two different currents going through it. We can use this equation. We have now successfully derived voltage and current dividers. Thank you so much for watching the video, and gig 'em with all your studies.